Hello, this is Brian Raya with assignment number 3 for the engine class. Assignment number 3 covers OBBs and all their respective collision types. So I'll start off the demo showing off that my soldier is an OBB. So the box rotates in world space. I can show that off with the GodCam. So as you can see, the box rotates. The frigate right here is an AABB. This collision will test the AABB and the OBB. So as you can see, the box at the bottom turns red, and we get a little message right here that says collision. Failed at 1 is for the tank. So I'll back off. Again, you can see that collision is no longer marked. And when I collide with the tank, which is another OBB, so this is an OBB collision, I'll enter the tank. So there I enter the tank, collision is marked, and we stop testing. But when I exit, I now have a B sphere. So now when my B sphere collides with my OBB, that would be the last test. So there's the collision, and I enter the tank once again. I will exit out and just briefly go into the code. My OBB computes the min and the max point, as well as stores the world position of the object. My AABB now does the exact same thing, and they both derive from the collision volume bounding box, which in turn has its world min and max point that both bounding box volumes inherit from, and the calculation for the collision types are as followed. So for an OBB and B sphere, we calculate the inverse world, so we get the OBB in local space. We calculate the point of the second sphere to the local space of our OBB. We clamp it, and we do our the rest of our math to check to see if a collision has occurred. And up next would be our OBB with an AABB. And we get our two center points, we multiply it by our world, and we get our original tests, so 1, 2, and 3, 4, 5, and 6 being the local x, y, and z for object 1 and object 2 respectively. And we test our SATs on these 6, and the cross product of the combination of the rest. So we have 15 tests altogether. Right now they're all currently in this function, but I plan to scroll them away and have a few helper functions for this. But the very first thing we do is we check that our magnitude of v is greater than 0, or the smallest possible number. We get d being the distance between the 2 points projected onto the axis we are currently testing on. PA is the closest interval on the given axis of our ABB and our OBB, both of them. And we compare the distance between the 2 center points with the 2 maximum PA and PB, and we check to see if it fails to get an early out. If it doesn't, we move on to the next axis to test, which is the y of object 1, the z of object 1, object 2, x, y, and z, and then the cross products of each of those. So at the very end, we end up with all 15 tests, and at the very end we mark if everything has if a return has not failed in this case, and we go false, then at the very end we just return true, and we mark that as a collision. OBB and OBBs are identical, to the one that I just shown, because an ABP is just, in essence, the same math, but moving on, we have our calculation for projection. We also have, this is the math for calculating D, or the distance between the two center points, and its projection on axis V. And to find our closest interval, we just check for the sign of V prime, which is the axis we're testing on, given the local space of whatever bounding box volume we are currently testing. So if it's positive, positive, we take the max of our object, and that would be what we'll later use for our projection. But again, we have all cases here, and we extract those, our x, y, and z coordinates. At the very end, we just return the length of that vector projected onto whatever axis we are currently testing on. At the very end, all this comes together and marks all of the collisions. For my game, I've only worked on a few tweaks. Things that I did not know is because I enter in and out of the tank every once in a while, some errors sometimes occurred because I wasn't updating the collision data, and I was working on those errors for this week. When it comes to my personal project, I don't have anything presentable for this week, but I should start on that this weekend. Other than that, that covers, I think, everything for this week's sprint. Thank you very much.